So today we're going to be reviewing. You've got a quiz coming up, so I want to go through some review problems. So looking at a regular parent function of a quadratic, it's sitting there at the vertex at 0, 0, and then it's 1 over and 1 up, negative 1 over and 1 up, 2 over and 4 up, negative 2 over and 4 up. That's what your normal y equals x squared is. Now this one here has been moved. Normally it's supposed to be sitting over here at 0, 0, but it's moved to the right too. So I'm going to make sure I'm going to write myself a note over here that we moved it right too. And then I'm going to look at my ordered pairs here. I'm going to go 1 over here, and I'm going to go going 1 over. And notice I'm going 1 up here. So that is, and then when I also go in this direction, I'm going to go 1 over and 1 up. So it is doing exactly what this graph did. Your parent function over here went 1 over and 1 up, 1 over and 1 up. So it's doing exactly the same thing, so we know that the slope in front of it, or that number being multiplied in front, is not going to change. And we haven't moved it up or down, so we're good. So let's write it out. Y equals, and moving it right to 2 there, it's x minus 2 squared. And then we don't have to do anything with adding or subtracting on the outside, and then there's nothing in front yet. Let's come down here and look at the second one down here. We've got another graph down here. So notice the vertex of this one is sitting down there at negative 9. So it started, remember our parent graph there is sitting up there at 0, 0, and it looks like we just moved it straight down to negative 9 there. So moving it straight down from negative 9, I'm going to say down 9. And we got to also check to see, as we did up here on the parent function before, we said this one's going over 1 and up 1. So over 1, up 1. So let's see if that does the same thing on our graph down here. Am I going over 1 and up 1? Yeah, I'm going over 1 and up 1. What about in this direction? I'm going over 1, up 1? Yeah. So it is working. So that number in the front that sometimes you have to put, it's not going to be there. So y equals x. Oh, I can just say x. If you want to put x minus 0, you could. You don't need it. Most of you are just going to probably just tell me x squared and then move down 9. And again, if you like to put 1, 1 in here, that 1, 1 here would be out here in front, but you don't need to do that. So coming over here, looking back at your parent function, the very first one we started there with, again, your vertex is sitting there at 0, 0. This vertex is sitting over here at 1, 3. So we've moved it right 1 and up 3. And the other thing we got to check is we got to check to see if that 1, 1 thing is in 1, 1. Is it going over 1 and up 1? Over 1 and up 1? Let's see. So I'm going over 1 and up 2. Over 1 and up 2. So you're going to have that vertical stretch factor of 2. So let's write out the equation here. So it goes y equals, the 2 is going to go out in front. Remember, rise or run, so it's 2 over 1, which is 2. And then we've got x going to the right, minus 1 squared, and then up 3, which is plus 3. So there we've got our nice equation. So for each quadratic equation, we're supposed to identify the vertex, identify the line of symmetry, identify the min or max, and then graph it out. So for this one right here, if you remember how this form goes, it goes x minus h squared plus k. And then you can put the a value here in front if you want. And then the hk here ends up being your vertex. So I always think inside there, it's x plus 2 in here. I always think inside there of how do I get 0 when x is negative 2. And then on the outside there, I have a minus 1. So I say my vertex there is negative 2, negative 1. Now you could graph it on your graphing calculator too and see where the vertex is sitting at that if that doesn't make sense to you. So my vertex, I've identified it. That was part A. Gonna make sure I answer all my parts here. it says identify the line of symmetry. The line of symmetry always goes to the x value of the vertex, so x equals -2. And then part C there says identify the max or min. So since this parabola here, since your a value here is 1 here, and that's positive, we know our parabola here is going to open upward, and therefore we have a min. So part C there is going to be min, and the min always matches the y value of your vertex, so your min there equals -1. So let's draw this in here. So we've got our line of symmetry. We've got our vertex there is at -2, -1. And we need another point there. So what you can do for one like this is just go ahead and pick an x value over here on the left-hand side, like -3, and then just put it back into your function. So y equals -3 plus 2 squared minus 1. And -3 plus 2 here is -1 squared minus 1, and I get 1 minus 1. Again, just put this directly in your calculator. Just put -3 plus 2 squared minus 1. So I'm just taking the -3 and plugging it up in here in the very beginning. So I'm getting -3, 0 there is my ordered pair. So -3, 0. So since I have that one, since that one's 1 away from the line of symmetry, then there's reflected over that vertical axis there, I get -1, 0, and I can simply connect my points. So I'm always using symmetry there to get my second point. It makes it easy. Next one here is a different form. So this one's a little bit different here. It says identify the vertex of this one. So I'm actually going to find my line of symmetry here first. If you remember how to find the line of symmetry, it's opposite of b over 2a. My b value here is -2, so the opposite of -2 there is 2. All over 2 times my a value there of 1. So I end up getting 1. So x there equals 1. So my vertex is 1 something. So I have to plug 1 back up there in my function. So 1 squared minus 2 times 1 minus 1. So I end up getting a -3, it looks like. No, -2. So putting that in there, I get 1, -2. So 1, -2, plotting that. And then for this one, this is that special one, the c value out here, c equals -1, and that's my y-intercept. This only works if it's in the form of ax squared plus bx plus c. It doesn't work when it's in your other form there, the vertex form. So my y-intercept there is at -1. And so from the line of symmetry, that -1 is 1 away, so there's 1 on the other side here that's 1 away. So I can just connect those points, and then I have my nice graph. So I've just got part C here left. Remember, this opens upward now, so it has a min value. So if it's a min, and it equals the y value of my vertex there, so my min value there is -2. So basically my smallest y value, the smallest y value there is -2. So we have that. These are just simply foiling problems here. So if you FOIL this out, you can take first terms here, x times x is x squared. And then you've got your outers here, which is 1x or x. You got your inners here, which is a -2x. This is a plus 1x. On the outers here is plus 1x, and then on inners here is -2x. And then you've got your last terms here. -2 times 1 there is -2. Combine your middle terms there. You get x squared minus x minus 2. And then part B, very similar. I can multiply my first terms there. I get 9x squared. I can multiply my inners and my outers here, so I get plus 6x minus 6x. And then my last terms here, I get a -4. Combining those middle terms, notice they go away because those are just 0, so I can say 9x squared minus 4. And then letter C here, you have to recognize that's x minus 5 times x minus 5. That's what that squared means. It means there's 2 x minus 5s. So now I can FOIL that out. X times x is x squared. And then I've got a minus 5x and a minus 5x. And then I simply have those last two terms, the -5 times a -5 there is a plus 25. So combining those middle terms there, I get x squared minus 10x plus 25. So we simplify those, put it back together. And then this one here is very similar. You got a rectangle here. The length is x plus 5. The width is x minus 3. We're supposed to find the area. Well, we know area of a rectangle is length times width. So our length is x plus 5. Our width is x minus 3. Let's just go ahead and simply multiply those together. So multiplying, foiling this out, we get x squared. And then we got minus 3x plus 5x. And then multiplying those last terms there, you got 5 times a negative 3 there is a negative 15. Combine the middle terms there, we get x squared plus 2x minus 15. So there's the area of my rectangle. A flat square roof needs a square patch to seal a leak. The side of the length of the roof is 2x plus 5 feet, and the side length of the patch is x minus 1 feet. There's a g missing in there. What is the area of the good part of the roof? So to do this one here, if you remember, area of a square here is just length times width, or side times side here. So we can take 2x plus 5 times 2x plus 5. That'll give me the area of this whole entire square here. But we're supposed to subtract off the part that's leaking here, which is the x minus 1 there, so squared. So x minus 1 times x minus 1. So what I'm going to do here is I'm going to FOIL this out and FOIL this out. So really we're trying to figure out this part in here. What's the area of that part that's all colored in there. So FOILing this first part out here, I get 2x times 2x there is 4x squared. 2x times 5 is plus 10x. 5 times 2x there is 10x. And 5 times 5 there is 25. And then over here, I'm going to FOIL this out. I get x times x is x squared. X times a negative 1 is a negative 1x, or negative x. Negative 1 times x is a negative x. And negative 1 times negative 1 is plus 1. So now I'm going to combine my like terms. So 4x squared plus 20x plus 25. And then combining my like terms over here, I get a minus 2x plus 1. Then my last thing I'm going to do is distribute that minus sign through. It's a minus everything over there. So I got to subtract everything off. So I got 4x squared before I combine my like terms plus 2x plus 25 minus x squared. We've got a minus and a minus in here. I get a plus 2x. And then I've got a minus and I've got a plus 1 here, which gives me a minus 1. So combining my like terms there, I've got 4x squared minus x squared there gives me a 3x squared. I've got a 20x and a plus 2x there gives me a plus 22x. And then we've got a 25 minus 1 there is a plus 24. So what is the area of the good part of the roof? We have it right there, 3x squared plus 22x plus 24. So I'm going to kind of mark that so they can see that. That's what I am intending to show as my final answer. All right, so almost done. Then we got one more. This one here is a cylinder, and the cylinder kind of looks like a can of soup. Draw that out perfectly, but there we go. So the volume, that's how much is going inside there. How much does it contain? It says pi r squared times the height. So our pi there, key there, button there, we're just going to leave there. We just leave pi alone. It says the radius of this problem here is x plus 3. So I'm going to substitute x plus 3 in for r. And then it says it has a height of 6 meters. So I'm going to put 6 in for the height. So I'm going to leave pi alone. X plus 3 squared is x plus 3 times x plus 3. And then I got times 6. So I'm just going to FOIL this out. I'm going to put the 6 pi out here in front. So if I FOIL that out, I get x squared plus 3x plus 3x plus 9. Combine my middle terms there, and I get x squared plus 6x plus 9. So there we have it. That's the volume of that cylinder.